A motor neuron of the spinal cord is activated, and action potential, or AP, exits the spinal cord. The axon branches to a motor unit to supply muscle fibers, and AP is transferred to a motor end plate on each muscle fiber. At the motor end plate, the AP causes the release of packets of acetylcholine, or ACH, into the synaptic clefts. ACH causes the electrical resting potential under the motor end plate to change, and this then initiates an AP that pauses in both directions along the surface of the muscle fiber. The AP spreads inside the muscle fiber at the opening of each transverse tubule onto the muscle fiber surface. At each point where a transverse tubule touches part of the sarcoplasmic reticulum, or SR, it causes the SR to release calcium plus 2 ions. Due to the release of calcium plus 2 ions, there is movement of troponin and tropomyosin on their thin filaments, which enables the myosin molecule heads to grab and move their way along the thin filaments. ACH at the neuromuscular junction is broken down by ACHE, or acetylcholine terase, which stops the flow of AP. The SR stops the release of calcium and starts to call back all the calcium ions it had released. So with the absence of calcium ions, a change in the process of troponin and tropomyosin would block the action of the myosin molecule heads, and contraction stops. Lastly, in a human being, an external stretching force, gravity, pulls the muscle back to its original length.